Hello and welcome to our Chemistry Practical podcast. We're here to try and make this daunting experiment a bit easier to understand. Just keep in mind that this isn't instead of your lab manual, more of an aid. So let's get to it. Today we'll be talking through experiment 173, the rate of hydrolysis of 2-methyl 2-chloropropane. Don't worry though, it sounds a lot worse than it is.
Just a few things to keep in mind. 2-chloro, 2-methyl propane and tertiary butyl chloride are highly flammable, so keep them away from flames and don't inhale them.
So, to start off the experiment, you first have to calibrate the pH probe. To do this, you must pour out the two buffer solutions into two separate beakers. Click the Cal button on the pH probe. It shall say Cal 1 ready. Then carefully take out the probe out of the solution. You may need to give it a little wiggle.
Rinse the probe with deionized water and blow dry with tissue. Place it in the buffer of pH 7. When it stabilizes and the graph icon appears, press the Cal button again. Make sure it reads Cal Oct before taking the probe out and rinsing again.
Repeat this but in the buffer of pH 4. The probe is now calibrated and you can then place the probe back in the bottled solution for the time being.
Next, you should prepare your solvent mixtures for testing. Pour 100 millilitres of the methanol water solvent mixture into each of the 4 volumetric flasks. Use a boss and clamp to keep 2 of the flasks in the water bath. Note the temperature of the bath. It should be 40 degrees Celsius, but if you record the real value, then that doesn't really matter. Also check what temperature the temperature probe says the room is.
Using the graduated pipette, measure out 1 centimeter cubed of tertiary butyl chloride.
You will need a table for the next bit to record the pH at different times. Take an initial reading, and then once the tertiary butyl chloride is added, a measurement is needed to be taken in very small time frames, such as every 5 seconds, until the reaction starts to slow down a bit. This tends to happen around or before the 2-minute mark. After that, you should choose larger intervals to measure the pH until the reaction evens out. It will take at least 10 minutes.
The best way to go about doing this is to have one person timing and taking notes of the measurements the other person with the probe is taking.
When one is finished, keep the flask and label it for later readings. Then move on to the next flask, ensuring that you recalibrate the pH probe between each test. Once all the tests are done, you are going to take one last pH reading of each flask. These pHs can be put into the equation 10 to the minus pH to find out the H plus infinity values.
Then that's the experiment finished.
On to the write-up. Sorry to say this, but the proforma isn't a quick one, so you'll have to set aside a lot of time for it.
The main equations you'll need to know for this write-up are the concentration of tertiary butyl chloride equals the H plus concentration in infinity minus the H plus concentration. The next one is the natural log of A equals the natural log of A initially minus K2. And the last one is log of K1 over K2 is equal to the activation energy over R multiplied by 1 over T2 minus 1 over T1.
This proforma also includes using a lot of Excel. The first section is creating tables, and since there are a lot of values to calculate, we suggest using a shortcut to save some time and get Excel to calculate everything for you.
For the concentration of H+, simply type in 10, then up arrow, then click the cell of the pH.
You can do a similar thing for the log of tertiary butyl chloride by using equals natural logs ln, then the cell you want.
Then to find the gradient of your graphs, click the Add button and show a trend line. From there you can follow the arrow along to more options and display the equation on this chart. Using y equals mx plus c, you should be able to read the gradient off no problem.
The last tip we have is to talk about all the data analysis points that are mentioned in your lab book in the discussion section. This will probably require some research.
After that, you have your freedom back for a while, so we hope that helped and good luck!